somewhere inside an exchange's compliance team, or a protocol's allocation review, the week before a token launch, 11 wallets just got flagged together. None of them share a name, none of them share an email, none of them ever logged into the same account. What they share is a pattern. They funded themselves from the same source address, they moved within the same 3-minute window, and they claimed the same testnet quest in the same order. Individually, any one of those 11 wallets looks like an ordinary user. Together, they stopped looking like 11 different people. This is the story of how that clustering actually works, and how someone with real, honest reasons to run more than one wallet keeps their own activity from ever looking like that. 4. The setup. Start with why this exists at all. An airdrop is a limited pool of tokens, and a protocol handing that pool out wants it to reach as many genuine separate users as it can, not a handful of people each pretending to be 20. Every wallet that gets counted as a duplicate of another is, in effect, a real user somewhere else getting a smaller share. So before the tokens ever move, most serious protocols run some version of the same question over their entire user base. Does this look like one person operating many wallets to multiply their share? That question is the whole reason Sybil detection exists, and it shapes almost everything that happens next, from how a protocol scores usage, to how aggressively it filters wallets right before a snapshot, to how much of the total supply even gets reserved for a later "we caught some Sybil's clawback" round. What a graph actually sees. Here is the part that surprises people the first time they hear it. None of this starts from identity. Nobody is checking a passport, and nobody needs to. What a chain analyst actually builds is a graph, a map of relationships where wallets are dots and every transaction between them is a line. The graph does not know or care who a wallet belongs to. It only knows that a line connects two dots, and that certain shapes of lines, certain dense little clusters of dots that all move together, are far more likely to belong to one operator than to a dozen strangers who happen to like the same protocol. A graph with thousands of wallets on it looks like noise until you start coloring in the dense little knots, and it is those knots that get a second look. The funding fingerprint of every signal in that graph, one is by far the loudest, where the money came from in the first place. When many wallets are funded from a single source address, especially in a tight burst, that is the single strongest, most common tell in the entire toolkit. It makes sense why it happens this way. Funding many wallets from one place is administratively convenient, and convenience is exactly what shows up as a bright, obvious cluster on the graph. 10 wallets that each received a small, similar amount from the same address within the same hour draw a shape that a dozen genuine strangers, funding themselves independently over months, essentially never draw by accident. The graph is not offended by convenience, it just notices it, and it notices it early, often before a single testnet action even happens. Timing as a signature. Money is not the only fingerprint, time is another. Actions taken minutes apart across many different wallets, repeated across weeks, form a rhythm that two genuinely independent people almost never share by coincidence. Real, unrelated humans do not swap on the same protocol within the same 3-minute window every single week for months. They have different schedules, different time zones, different reasons for logging on. When that rhythm shows up across a dozen wallets instead, it reads as coordination even if not one of those wallets shares a single other data point with the others, and the more weeks the rhythm repeats, the more confident the signal gets. Gas and behavior patterns. Then there are the smaller, quieter details most people never think about at all. Identical gas settings across wallets, the same price bid down to a fraction of a unit, identical transaction ordering, the exact same 3 actions, in the exact same sequence, every single time. Identical click paths through the same decentralized app, as if each wallet were following a script rather than a person making their own independent decisions in their own order. No single one of these details proves anything on its own. Plenty of honest users share a wallet's default gas setting, purely by coincidence. Stacked together across many wallets though, they start to look less like coincidence and more like a signature, the digital equivalent of 11 people filling out the same form in the same handwriting, where the money reconverges. Here is the detail that undoes almost everyone who tries to separate wallets carefully upstream. Eventually, the money has to go somewhere. Every wallet, sooner or later, needs to cash out. And when the outputs of many different wallets all drain back into one destination, whether that is one exchange deposit address or one final wallet, all of the careful separation built up earlier gets erased in a single line on the graph. The beginning of the story can look perfectly separate, 10 unrelated origins, 10 unrelated timelines. The ending very often does not, because 10 different rivers still only empty into one sea, and analysts watch the sea just as closely as the source. The tooling and the arms race, none of this is done by hand. Protocols, exchanges, and chain analysis vendors run heuristic clustering algorithms over public chain data, the same data anyone can see on a block explorer, just processed at a scale no person could do manually. A handful of specialist firms build risk scoring products specifically for this, and protocols license that scoring the way a bank might license a fraud detection service, and it never really stops evolving. Every season a new signal gets discovered, folded into the model, and applied retroactively to wallets that thought their history was already settled. Detection a season ago is not detection today, and it will not be detection next season either. It only ever gets a wider set of signals to weigh. What happens to a flag cluster? Flagging is not the end of the story. It is the start of a decision. Some protocols simply zero out every wallet in a flag cluster and move on, treating the whole group as one entity that gets one share or no share at all. Others take a softer route, capping the reward per cluster instead of removing it entirely, on the theory that even a real operator with several honest wallets should still get counted once, not many times over. A few run a manual review queue, where a flag cluster can appeal and explain the shared funding, though that process is slow, inconsistent between protocols, and offers no guarantee either way. None of these outcomes are announced in advance, and a wallet usually only learns which policy applied to it after the tokens have already been distributed to everyone else. The false positive problem, and this is where the picture gets genuinely uncomfortable, because the same patterns that flag a farm also describe a lot of completely honest situations. A small family that shares one exchange account, a tiny team that funds its shared treasury from one place, a friend group that all got into a protocol together and naturally moved in similar time frames because they heard about it from the same conversation. None of that is a Sybil operation. All of it can trigger the exact same signals, and the graph on its own has no way to tell the difference between coordinated abuse and ordinary shared circumstance. That ambiguity is not a bug the industry has quietly fixed. It is a permanent structural feature of scoring behavior instead of identity that looks like one-person bar, which is why it matters to be precise about what this actually is. None of this proves identity, and none of it is really trying to. It is a probability score, a confidence level that a given cluster of wallets is more likely one operator than many, and every protocol sets its own threshold for how confident is confident enough to act on. Some thresholds are conservative and only catch the most blatant mechanical patterns. Others are aggressive and catch a wider net, including some genuinely honest wallets caught in the wrong shape at the wrong time, which is exactly why some protocols run an appeals process for wallets that got filtered out unfairly. How honest multi-wallet users reduce accidental linkage. So for someone who genuinely does have more than one wallet for real, separate reasons, a personal wallet, a trading wallet, a small team's wallet, the honest goal is not to defeat a detection system, it is to avoid accidentally recreating the exact pattern that system was built to catch. That mostly comes down to letting real separation actually be separation, funding from more than one source over real stretches of time rather than one convenient burst, and letting each wallet's activity reflect what that wallet is actually for, rather than mirroring the other's action for action. A personal wallet behaves like a person's actual habits. A team treasury behaves like a team's actual schedule. None of that is a trick, and none of it is designed around what any specific detector looks for. It is closer to just not manufacturing the coincidence in the first place, because the coincidence, not the number of wallets, is what actually draws attention. The limits of any of this, it is worth being blunt about the ceiling here too. Nothing in this video, and nothing available anywhere, promises invisibility from analysis that has enough data and enough motivation behind it. Clustering techniques keep improving, the dataset only ever grows, and a determined enough look with enough time and enough resources will eventually surface structural patterns that genuinely exist. This is not a video about outrunning that permanently, because no honest video can promise that, and anyone selling a guaranteed method to beat detection forever is selling something that does not exist. The non-tubies, why this keeps mattering. Every season, the detection gets a little sharper, because every season it has a larger, richer dataset to learn from. The honest way to hold up under that isn't a new evasive trick. It's simpler and less exciting than that, actually operating the way separate, real usage would look in the first place. There is a slower, less flashy answer than most people want, but it is the one that keeps holding up season after season, long after any particular trick has been noticed and closed. I run real proxy and cloud phone infrastructure for a living, and I think about airdrop farming the same way, as operations, not a lottery ticket. The full breakdown of how this clustering actually works, plus the tools I personally trust for keeping wallets organized, are written up at airdropfarming.org. No hype, no guaranteed payout numbers, no promise that any of this is financial advice, just what actually holds up across a season. If that's the kind of channel you want more of, subscribe. Next time, the boring methodical checklist for deciding whether an airdrop is even worth qualifying for in the first place, before you spend a single dollar in gas finding out the hard way, because qualifying for the wrong protocol costs just as much gas as qualifying for the right one, and only one of those two outcomes is worth the effort.